Why do you think geometry feels like you switched from math to maybe art class when we jump into it? And then a whole lot of new definitions, new names for things that's just, well, it's just a little bit confusing. So if you've been moving through algebra and doing okay, right? Your numbers, equations, lines, you're that felt a little bit like math and a little bit abstract from what you were doing before. But now in geometry, it's just a little weird. So, or it is for a lot of people, I should say. So, why does it feel different? So, I'm going to talk about some strategies here to help you be more successful in the transition to geometry. But first, a couple of things that you'll notice that maybe is why it feels different. It's more visual. Geometry is by its very nature a visual kind of concept, and that should be a good thing, but for a lot of people it throws them off. So it's not just numbers. Geometry is pictures, shapes, relationships between shapes. Number two, it's got proofs in it. Proofs is something that most of us, until we get to geometry, have never seen, and many of us grow to have a wonderful hatred of. I did. I didn't know why I was proving things, what the point of this proof thing was. I just didn't get what we were doing. And it wasn't until much later that somebody explained to me what was going on. And proofs is actually, once you get it, once you understand a concept, they actually are pretty simple usually, and they really help you think through things logically. And that gives us to the third reason that geometry is different, is that we are really mixing a little bit of logic with creativity. The two, if you're an art person, or a music person, you may not think they go together. Of course, if you've learned music, you know that there's logic that goes with it. But for a lot of people, creativity is the opposite of logic. Well, no, not really. What we're doing here is a little bit of both. So geometry feels weird, and if that's where you are, and if you're a parent trying to guide somebody through geometry, and you probably remember some of the concepts because you use them quite often, like calculating area and perimeter and things like that. But you might not remember some of the more weird, detailed things. They're not necessarily weird, but we don't remember them, vocabulary being one. So let me give you just a couple of strategies to help you, if you're the student or if you're the parent or teacher, to help you just go through geometry and get through this smoother. We are using the book that we use for our course is Harold Jacobs' Geometry. I think the cover looks different than this right now because it's under a different publisher, but it's the same book. So I'll refer to that a couple of times. But hey, geometry is geometry. This book is awesome because it's doing more of what I am talking about than maybe some other courses do, like some other books and textbooks. First of all, you need to draw everything out. Draw everything. And there's something about us when we're doing mathematics that we don't want to pick up pen and paper. And this is always a struggle as you go from the younger grades where we can maybe do math in our head. We memorize things. We memorize times tables. And then we memorize all this stuff. And later we expect kids to pick up a pen and a pencil and paper and to write it. And we've trained them just the opposite, to not do that in a lot of aspects. But in this case, draw things. Everything in geometry is a shape, is a drawing. So sketch it out. It doesn't have to be perfect. We're not looking for drawing. What you're looking for, because you're not drawing it for presentation as much as to help you think. And seeing a picture is really powerful. And the more you can do that, and the quicker you can sketch. And this is really important as you start moving into ACTs and SATs, if that's where you're heading. But even in just thinking about things, I don't know how many times that doing projects where we're building something, or we are constructing something at a barn, or just talking about redecorating in a house, Uh, and just practical everyday problems that we are drawing pictures to help us understand. And so draw things. Don't hesitate to, when you see a figure in the book, so get you a piece of paper, sketch it out yourself, and then start writing on it, whatever you need to write on it, and to help you think through things. It's really powerful. I know people think, well, if I have to pick up a pencil and a pen and do some of the things you're about to talk about, even in the other ones, it takes more time. It may take a little more time up front, but you start to move at a faster pace, not only in geometry, but in later mathematics and either even other courses that you may not think have anything to do with mathematics. Anything in the science field, but anything where you need to do logical reasoning. So draw everything out, or don't hesitate to draw, I should say. Maybe everything doesn't need to be drawn, but if you're struggling in the slightest, if you're like, what does that mean? Pick up a pencil. And what you're doing is you're getting your head moving. It's not about what's on paper. It's about the process of thinking. Number 2 is learn the vocabulary. Oh, God. That just is terrible sounding, right? My goodness, why would we want to learn vocabulary? So if we look at the back of the book, we see a bunch of terms. Wait a minute, that's not the back of the book. I'm sorry. So you see a bunch of theorems here that are in the book and corollaries, and you're probably thinking, oh my goodness, I never want to see that stuff again. And a bunch of definitions. And it all maybe looks daunting. If you're just flipping through it, it probably looks a little daunting. Theorem 1, Theorem 2, Theorem 3, and so on and so forth. But it's not. It's actually a bit freeing. It's once you understand some guidelines, you know how to play. It's like playing a sport, right? Once you understand the rules, you understand where the boundaries are. You understand what you can and cannot do. You understand how many times you get to be offensive and what do you do on defense. The rules are boundaries, and they help you succeed in the game. And so these are rules, or sometimes even insights. But it's the vocabulary. And in geometry, we use a lot of vocabulary. Things like congruent, bisect, parallel, transversals. And they mean something, and you're going to be struggling. So when you see these words and you don't know what they mean, do what we've always been told. If I see a word, look it up in the dictionary, if that's such a thing anymore. If you see a word in a problem that says bisect these two lines, and you're trying to figure out what it means, if you don't understand what bisect means, you miss the whole point of the problem. And many of the questions we get in support are people they don't understand what the words mean. And they're all here in the back of the book. So if you're in like chapter 7 and you're working a problem and you don't know what it is, the back of the book here is lined out by chapter. So you can look at the summary of the chapters, but you can also look up the different theorems, and it just really helped in the definitions. And you could just look it up. I don't remember about what bisect is. It was covered back in chapter 2 or something. I don't remember. You're not going to remember where it was covered. So just look it up in the back of the book. It's got this dictionary type of thing going on back here. And you can look it up, and it will tell you, hey, this is covered back in chapter 2 or something. But once you understand what it means, you probably got that. It's just like when I tell you two lines are parallel. You probably know that. When I tell you they're perpendicular, you might not know that. When I tell you they're congruent, wait a minute, what does that mean? Or there are transversals. When I start using terms like that, they have specific meanings. Those specific meanings help you solve the problems. And you'll see a lot of this in the ACT, SAT exams, where just knowing the word, the problem is solved. So get to know them. It's not like there's tons of them. um, and they tend to overlap. Once you know a couple of them, you're really moving forward, and you're not going to memorize every theorem. Think about Pythagorean's theorem, for instance, that some of you might still remember, at least that there is such a thing. And things like the quadratic equation or a linear equation, those things, whether you do them every day, the words probably mean something to you, and when you see it, you might remember. So that's what there's a couple of key ones, and you'll use them over and over again. So when you see vocabulary and you don't know what it means, look it up, because it's probably the solution to the problem is just knowing what that means. So number 3 is think in steps. Right? This is not 2 plus 2. Just write down 4. Think in steps, kind of like we do in algebra, right? You see some things. What you're doing in algebra is you're oftentimes, okay, I'm going to move everything to one side of the equation. I'm going to simplify and add things together, and I'll write down these things in different lines, right? The first line is the problem. The second line is me subtracting and moving things to every side. The third line is me adding things together, and maybe the fourth line is solving the problem. It's a step-by-step process. That's really what geometry is, and especially when you get to proofs. When you're doing proofs or problems, and in this book, and not all books do it this way, but in Harold Jacobs' book, many of the problems are laid out like proofs. You don't really see that until you understand what's going on in a proof. But he'll have like a picture, and it will have a question, and a second question, and a third question, and a fourth question, and it's all related back to that picture. And really what he's doing is walking you through a proof. He's trying to get you from point A and to point Z, and trying to see this is what's happening. So he's giving you problems in steps. So he could have just started with the image and said, hey, what's the last step? And then you are going to go through the process, but he's walking you through this all the way through the book, and then sometimes he'll say, okay, now I'm going to stop here, and you figure this out. So it's a great book for doing that. So it's steps. Break it down. Start with things like, what do I know? And then what can I show next? So we have another video on doing proofs. We'll put down here in the bottom. But that, if you're probably in geometry, proofs is the deal killer for most of us. It's the thing that we really struggle with. Once you can get your head around that, and what I'm talking about is the basics of this is it changes everything. All right. So number 4, which is related, is practice the proof problems, proof patterns. I'm sorry. Just like in algebra, you had some formulas to memorize, right? There were so few. Geometry has more what we would say is proof patterns, and you'll start to see patterns of proofs, and it's always start with a given, and just kind of go from there, and just write down everything you know, write down what they're asking, what's given, and there's these patterns, and go back to the video on the proofs here that will help you on that also. But get used to that. It introduces you in this book. It introduces that kind of slowly, and so it's easy to walk into. Number 5 and the last one is connect geometry to the world. Now, geometry. Algebra is everywhere. You're using, on some previous videos, we've talked about you do algebra everywhere, whether you think about it or not, whether you even truly understand algebra or not. Geometry is everywhere. If you've ever played billiards or basketball or any kind of sport, buildings, you even see geometry in music. That's a little connection that a lot of people don't see. You see it in video games. You see geometry everywhere. And so start looking for it. Start looking for it as you're studying things like shapes and circles and triangles and these things, yeah, you'll start to see, because geometry is teaching you some relationships between things. You'll start to see those things everywhere, and that helps you connect the dots. Now, again, this textbook, the Harold Jacobs textbook, is great at that because almost all the problems he gives you in the book are related to real life. They're not, hey, here's two lines at random, figure out, are they parallel or not. He'll be talking about, hey, here's a ladder hanging against a wall and they're trying to paint the room. So it's real stuff. It's stuff that you can see in real life every single day. So let me just walk through those once again. Drawing everything, draw it out. Learning the vocabulary, look up the words when you run into them. Think in systems or think in steps. So don't think about, I'm going to write this down in one step. Practice proof patterns. There's patterns to proofs, and you'll learn them very early, and you'll see them over and over. Connect geometry to the real world. Those 5 things will just make geometry just much smoother transition, and you can do some of these things even before you jump into geometry while you're still in algebra. So this is a lot of the reasons that geometry feels hard. Usually once people get through some of these things, geometry is actually much easier because it's more visual, because for most of us that's a plus. But it can be hard at first to get past. We're shifting a few gears here, thinking more logic, thinking more shapes, thinking more getting from point A to point B, and proofs, a lot more thinking on paper. So the things that we're just maybe not as used to as we were in algebra. But moving forward into Algebra 2 and trig, calculus, and anything else that you're doing, it will be the foundation. So it's important. Just slow it down if you need to, speed it up if you need to, whatever. But take these 5 steps, and they'll help you get through this. So hopefully this helps you. So again, we'll have some link down below to the proof video, as well as to some of our toolbox tools that we have, the resources that we have available for you that will be down here below. So as always, subscribe if this is helpful to you. If you do need help, shoot us an email at support@AskDrCallahan.com. That's support@AskDrCallahan.com.